Welcome back. So Adnan, now we've got the world connected, right? We talked about connecting all these devices and the uses and the endless uses of them. Now what do we got to do? We got to move data. We got to move content between these things. So how are we going to do that?
Great question. So again, in the connect, move, control model, there is a lot going on that most businesses, most individuals do not even see or even conceive of. One of which is really the infrastructure. We take it for granted. We go to a Starbucks and we immediately expect wireless LAN. We go to the hotel, we pop up our computer, we automatically expect wireless LAN and connectivity. So the things that were very complex back in the day when they first rolled out 5, 6, 7, 8 years ago, now is a misnomer and we just expect it. But behind that, there's a huge amount of technology. And as we indicated earlier on the Connect module, or the pillar of Connect and the type of devices relative to the context, the policies, the individuals, the roles, why and who is accessing with what device, the same is contingent upon the move component. And the reason there is because you need to make sure you have a robust fixed line network, a wireless LAN network, a 3G, 4G network, or even a microwave point-to-point, point-to-multipoint network. Those are really the 4 or 5 main infrastructures that are leveraged today in order to transport information. So in order to really design the proper infrastructure, one has to really look at their entirety of their business. Who's accessing, from where, why, what level of information is being transported, and then of course based on that you determine what type of infrastructure you need and what type of security mechanisms you need to put around it in order to ensure an accurate and secure connection.
And let's talk about, we talked about the past and the future. Let's talk about, you couldn't even move the size of data 5 years ago. The bandwidth wasn't available, the pipes weren't available. As an example, I don't know how much it would have cost or if it would even have been available. I was driving 60 miles an hour down the highway, connected, checking my email and doing a WebEx at the same time. That was unheard of, 4 or 5 years ago?
Absolutely. Absolutely.
So there's tons of ways to connect, and what is the price of this connectivity doing? It's more available, I guess, out into more areas. It's more cost effective.
Yeah. So taking a step back, in the couple of earlier sessions that we did when we talked about the overall strategy and kind of all the factors that have driven the industry where it is today. One of the things that has been crucial to the evolution of mobility has been the core infrastructures of the network operators. Companies like Cisco, Juniper, Huawei, and others have built the MPLS backbone. So MPLS, I believe, is the true foundation of the majority, if not all, networks today that are enabling us to do the things that we do. And I'll give you an example. MPLS stands for multi-protocol label switching. Technology that was spearheaded by Cisco and others and really has taken the world by storm. What that really allows you to do is to take multiple data streams, voice, data, video, mission critical applications, plain email, whatever it may be, and use the same pipe and put different weights on how important that traffic is and be able to pump it through. The second thing it allows you to do is you no longer have to have a point-to-point connection. So between me and point A, I had to have a circuit, or I had to have a connectivity that was static. It was up all the time, right? Use it or lose it kind of thing. With MPLS, you basically build logical pipes to all the different locations that you want, and based on that, you really create a true mesh network. And on top of that, you put quality of service, you put SLAs or service level agreements in there to ensure that traffic is transported based on how important is it? Is it mission critical? Is it just a data batch file that I can upload at night when everybody's asleep? Is it a voice conversation? You drop a packet in voice conversation and you hear that the jitter, or you hear the echoing oftentimes on voice over IP. That's because packets are being dropped or the routes that they're taking are not as robust as others. So based on that core infrastructure is what's really enabled the things that you talked about earlier, to be driving on the freeway and being able to use your device and looking at your GPS. It's real-time base location services that the networks are identifying where your actual device is, and based on that emission of that signal, it's mapping you within 1 or 2 feet of that device, no matter how fast you're moving. So that could have never been conceived of many years ago. because it would have taken so much data, so much processing on the back end, so much CPU, so much infrastructure that was not there. And because of MPLS and because of the robustness of 3G, 4G, LTE type of networks and these devices and the capability and the processing power, we have brought all three together to enable some of these applications that you and I use every day and take for granted.
I'd be interested to understand what your opinion is. So you talked about these, these 4 ways to connect that are basically, kind of the biggest as it stands today. I mean, as we look globally, right? I mean, do you think that the future of this will look like much like what you described, how we're going to figure out how to use this existing pipe, this existing bandwidth smarter? I mean, do you think that there's basically that the bandwidth available is going to basically just go up continuously because of who knows what, or do you think there's going to be an entirely new protocol perhaps that comes out or a way to connect? I mean, what would your opinion on that be?
So having spent many years internationally, there's a couple of things going on. When you look at the international infrastructures, the majority of them are wireless. Specifically outside of Western Europe, right? Western Europe, the US, and these industrialized countries, when telephony first came out and infrastructure came out, they put copper down, they put the fiber down. But you look at your East Asia, you look at Middle East, Africa, and some of the Eastern European countries, they didn't have the money nor the ability to put that down. Mm-hmm. So what they did is they just threw up wireless networks. And overnight, they had robust networks that for years took us to get there. And that's why if you look in some areas internationally, they're more robust and more developed in terms of their true mobility utilization than we are here in the US. With ATT and the old MCI networks and Sprint networks, there's so much copper and fiber in the ground, and they finally have paid for it. It's a cash cow for them today. So they're going to leverage that as much as they can. And so what does that really mean? Well, to talk about the US, what you're going to see is new technologies for compression, dark fiber, where they're going to be using the light spectrum to take analog, from digital to light signals, and they transport that from point A to point B, and they reverse that whole process back to hand you that packet off, whether it's a voice conversation or a data conversation. Mm-hmm. So what you're going to see, different types of encapsulation, different types of technologies, different type of compression to transport information from point A to point B on existing fiber networks that by definition will allow you a more robust connection than your wireless interface or your GPS type of interface, right? You're going to see that in some of these developed countries, if not already. That will continue to evolve, and we'll continue to be able to see the robustness of transporting information at a much lower price than what it cost us a long time ago.
Right.
In the international arenas, you're going to start seeing more people leveraging the wireless networks. And what's going to happen is all the processing power and the horsepower that's going to be taking place will take place at the device, and the only thing that will be transported is the actual transaction, rather than what we're used to on the wired line, which is, request, response, mm-hmm. back and forth. You can't do that with wireless. So technologies will evolve in the wireless area to do that, to maximize what they've got, while at the same token, these wireless carrier networks will be compressing information when they send it over the air interface to allow more of a robustness. Mm-hmm. That's where your LTE comes in, your 4G, and so forth. It's that technology, it's those algorithms that have been created to increase the robustness of that transmission. That's what I perceive, at least for the next 5 to 10 years. And we may be approaching beam me up, Scotty,
Yeah.
I don't know, right? If I had a crystal ball, we'd all be billionaires.
Yeah,
so.
absolutely.
Well, I think one of the things that's clear though is, we've talked about how you connect these people, how you connect these devices, and how you want to move, right? You want to move data back and forth. So the next logical thing we're really going to cover is, so what about that data as it's passed back and forth, or who is that person? It's important to actually control what people have access to and make sure they don't get access to something that they shouldn't, right? And so that's definitely the next thing we're going to cover is that third pillar, which is control. So